The June solstice is a cosmic event that shapes life on Earth in ways we often overlook. On this day, the sun reaches its highest or lowest point in the sky, creating the longest day in one hemisphere and the shortest in the other. Did you know that above the Arctic Circle, the sun can shine for 24 hours straight during this time? The June solstice isn't just about daylight, it's a powerful reminder of our planet's incredible dance with the sun. What is the June solstice? The June solstice is one of nature's most fascinating astronomical events, marking a pivotal moment in Earth's yearly journey around the sun. On this day, the sun reaches its highest or lowest point relative to the celestial equator, creating a dramatic shift in daylight hours. This event officially signals the start of summer in the northern hemisphere, and winter in the southern hemisphere. But what exactly causes this phenomenon? It all comes down to the tilt of our planet. Earth is not perfectly upright. Instead, it leans at an angle of about 23.5 degrees. This tilt means that as Earth orbits the sun, different parts of the planet receive varying amounts of sunlight at different times of the year. During the June solstice, the North Pole tilts toward the sun, allowing the northern hemisphere to bask in longer daylight hours. Meanwhile, the southern hemisphere experiences shorter days and longer nights. This celestial dance has been observed and celebrated by humans for thousands of years, influencing calendars, agriculture, and cultural rituals worldwide. The June solstice is more than just a date on the calendar. It's a reminder of the intricate relationship between our planet and the sun, shaping life in countless ways. Why does the length of day vary? The length of the day during the June solstice is not random but a direct result of Earth's axial tilt and its orbit around the sun. Because the planet is tilted at about 23.5 degrees, the angle at which sunlight strikes different regions changes throughout the year. This tilt causes the sun to appear higher or lower in the sky depending on the season. During the June solstice, the northern hemisphere leans toward the sun, which means sunlight travels a longer path across the sky, resulting in extended daylight hours. Conversely, the southern hemisphere tilts away, receiving less direct sunlight and experiencing shorter days. This variation in sunlight affects everything from weather patterns to ecosystems. For example, longer days in the north encourage plants to grow and animals to breed, while shorter days in the south signal the approach of winter. The changing length of days also influences human behavior and culture, with many societies marking the solstice as a time of celebration and reflection. Understanding why day length varies helps us appreciate the complex mechanics of our planet's movement and its profound impact on life. Longest day in the northern hemisphere. When the June solstice arrives, the northern hemisphere enjoys its longest day of the year, a phenomenon that has fascinated people for centuries. This happens because the North Pole tilts closest to the sun, allowing sunlight to flood the sky for an extended period. In some places above the Arctic Circle, the sun doesn't set at all, creating the famous midnight sun. This extra daylight means more time to enjoy outdoor activities, soak up vitamin D, and connect with nature. It also triggers biological changes in plants and animals, encouraging growth, reproduction, and migration. The long day brings energy and vibrancy to human cultures as well, inspiring festivals, ceremonies, and traditions that celebrate light and life. From ancient stone circles aligned with the solstice sun to modern-day gatherings, this day is a powerful reminder of the Earth's rhythms. The longest day isn't just about more sunlight, it's about the connection between our planet's tilt and the sun's path, shaping the seasons and influencing life in profound ways. So when you experience that extra hour of daylight, you're witnessing a cosmic event that has been happening for millions of years. Shortest day in the southern hemisphere. While the northern hemisphere basks in extended daylight, the southern hemisphere experiences its shortest day during the June solstice. This contrast occurs because the South Pole tilts away from the sun, casting longer shadows and bringing extended nighttime hours. For those living in places like Australia, South Africa, and parts of South America, the June solstice signals the onset of winter, with cooler temperatures and shorter days. The reduced sunlight affects ecosystems, slowing plant growth and prompting animals to prepare for colder months. People adjust their routines, often spending more time indoors and celebrating winter festivals. Despite the chill, the solstice holds cultural significance here too, marking a time of reflection, rest, and renewal. It's a reminder that while the Earth's tilt brings change, it also creates balance. One hemisphere's longest day is the other's shortest. This interplay between light and dark, warmth and cold, shapes the planet's diverse climates and lifestyles. Understanding the southern hemisphere's solstice experience helps us appreciate the global impact of this astronomical event and the shared connection we all have with the sun's journey. Cultural significance of the June solstice. The June solstice has inspired countless cultures around the world, each celebrating this celestial milestone in unique and meaningful ways. From ancient times, people have recognized the solstice as a powerful moment of transition and renewal. Many festivals honor the sun's life-giving energy, symbolizing growth, fertility, and hope. For example, in Scandinavia, midsummer festivals light bonfires to celebrate the longest day, while in Mexico, indigenous communities hold rituals to honor the sun god. These traditions often include music, dance, and communal gatherings, reflecting humanity's deep connection to the natural world. The solstice also influenced ancient architecture, with monuments like Stonehenge and Newgrange aligned precisely to capture the first rays of the solstice sun. This alignment shows how early civilizations tracked time and seasons, using the solstice as a calendar marker. Celebrating the June solstice today continues this legacy, reminding us to pause, appreciate the changing seasons, and reconnect with the rhythms of our planet. It's a moment to honor light, life, and the enduring bond between Earth and Sun that shapes our existence. How the solstice affects nature. The impact of the June solstice extends far beyond just longer or shorter days. It profoundly affects the natural world. In the northern hemisphere, the surge of sunlight triggers a burst of activity in plants and animals. Trees and flowers grow rapidly, taking advantage of the extended daylight to photosynthesize more efficiently. Many animals use this time to mate, raise their young, or migrate to more favorable environments. The solstice acts as a natural signal, guiding behaviors that ensure survival through the changing seasons. Meanwhile, in the southern hemisphere, the shorter days and reduced sunlight slow down growth and encourage animals to prepare for winter's challenges. These seasonal rhythms create a delicate balance in ecosystems, where every species responds to the sun's changing position. Understanding this connection highlights how the June solstice is not just an astronomical event, but a vital driver of life's cycles on Earth. It's a reminder that our planet's tilt and orbit orchestrate a complex dance of light and dark, growth and rest, sustaining the diversity of life we see around us. Common myths and misconceptions. You know, a lot of people think the June solstice is the exact moment when the longest or shortest day happens, but honestly, the reality is a bit more fascinating and complex. The solstice, well, it actually marks the point when the sun reaches its highest or lowest position in the sky at noon, but the length of daylight changes gradually before and after this date. So, what that means is the longest day in the northern hemisphere and the shortest day in the southern hemisphere don't always fall exactly on the solstice itself. Instead, they usually occur within a few days on either side. This happens because of the way Earth's atmosphere bends sunlight, and also the planet's orbit isn't a perfect circle. It's just a little bit elliptical. These factors cause subtle shifts in sunrise and sunset times, creating a phenomenon called the solstice effect. Understanding this honestly helps debunk some common myths and really deepens our appreciation for the intricate dance between Earth and Sun. It's a good reminder that nature doesn't follow rigid rules but rather flows in cycles and rhythms that have fascinated humans for, well, thousands of years. So, the June solstice isn't just a single moment frozen in time. It's part of a beautiful ongoing process that shapes our experience of day and night. Climate impact of the June solstice. The June solstice doesn't just influence Earth's daylight hours, it also plays a crucial role in shaping our planet's climate patterns. As the northern hemisphere tilts toward the sun, it absorbs more solar energy, warming the atmosphere and oceans. This increase in heat drives weather systems, creating the summer season with its characteristic warmth and storms. Meanwhile, the southern hemisphere cools down, entering winter. These shifts in temperature affect wind patterns, ocean currents, and even rainfall distribution around the globe. For example, monsoon seasons in Asia are closely tied to the solstice's timing, bringing vital rains that support agriculture and ecosystems. The solstice's impact extends beyond just light and dark. It orchestrates the complex climate rhythms that sustain life on Earth. Understanding this connection helps us appreciate how a single astronomical event can ripple through the environment, influencing everything from daily weather to long-term climate trends. It's a powerful reminder of the delicate balance between Earth's tilt, the sun's energy, and the dynamic systems that keep our planet habitable. Cultural and mythological significance. The June solstice has long been a profound source of inspiration for art, literature, and mythology across diverse cultures, highlighting humanity's enduring fascination with the sun's immense power and influence. Throughout history, many ancient stories and legends have portrayed the solstice as a magical time when gods and spirits are believed to roam the earth, or when the veil between the physical world and the spiritual realm becomes thinnest. In Greek mythology, for instance, the solstice was closely associated with Apollo, the god of light, music, and prophecy, symbolizing illumination and divine insight. Similarly, Native American tribes traditionally held vibrant ceremonies to honor the sun's life-giving energy, using rhythmic dance, soulful song, and communal gatherings to celebrate the turning of the seasons and express gratitude for nature's cycles. Even in modern times, the solstice continues to inspire artists, poets, and writers who draw upon its rich symbolism to explore themes of transformation, renewal, hope, and the eternal dance between light and darkness. The solstice represents more than just an astronomical event. It serves as a powerful metaphor for change and rebirth, reminding us of our deep-rooted connection to the cosmos and the natural world. This unique moment in the year is where science and spirituality intersect, inviting wonder, reflection, and a sense of unity with the universe. Modern technology and the June solstice. Technology today allows us to observe the June solstice with incredible precision and detail, revealing new insights into this ancient event. Satellites orbiting Earth capture stunning images of sunlight patterns, while sophisticated instruments measure the sun's exact position and intensity. These tools help scientists track changes in Earth's tilt and orbit, improving climate models and our understanding of seasonal shifts. Additionally, digital apps and websites provide real-time solstice data, making it accessible to anyone curious about the sun's journey. This fusion of ancient knowledge and modern technology enriches our appreciation of the solstice, connecting us to a tradition that spans millennia. It also highlights how science continues to evolve, uncovering the subtle complexities of Earth's relationship with the sun. Whether you're a casual observer or a space enthusiast, technology invites you to witness the solstice in new ways, deepening your connection to the rhythms that govern life on our planet. Thanks for exploring the wonders of the June solstice with Space Facts. If you enjoyed this journey through Earth's cosmic dance, don't forget to hit that subscribe button and ring the bell icon, so you never miss an update on our amazing universe. We'd love to hear your thoughts. Drop a comment below sharing how the solstice affects your part of the world or any cool facts you know. Your support helps us bring more mind-blowing space content right to you. Stay curious, and see you in the next video. The moon is more than just a glowing orb in our night sky. It's a powerful force that has shaped Earth's tides, climate, and even the length of our days for billions of years. Did you know that the moon is slowly drifting away from Earth at about 3.8 centimeters per year? Now imagine what would happen if, instead of drifting away, it suddenly collided with our planet. Do you know the devastating effects such a cosmic crash could unleash? The moon's current orbit and stability. What if the moon suddenly stopped orbiting Earth and started drifting closer? The consequences would be immediate and terrifying. The moon's gravity is already responsible for the tides we see each day, but if it moved closer, those tides would become monstrous, flooding coastlines and swallowing entire cities. This gravitational tug-of-war would also trigger massive earthquakes and volcanic eruptions as the Earth's crust strains under the added stress. The atmosphere wouldn't escape unscathed either. Violent storms and unusual weather patterns would sweep across the globe, making survival even harder. The moon's approach would disrupt the delicate balance that has kept Earth stable for billions of years, and the closer it got, the more chaotic life would become. This isn't just about water rising or storms intensifying. This is a complete upheaval of the planet's natural rhythms. The moon's pull would literally shake the ground beneath our feet, crack open the Earth's surface, and unleash forces that could reshape continents. It's a reminder that even our closest celestial neighbor plays a critical role in maintaining the balance of life on Earth. Without that balance, the planet would be a very different, far more hostile place. The initial approach and gravitational effects. The moon drifting closer to Earth wouldn't just cause wild tides and earthquakes. It would unleash a storm of atmospheric chaos like we've never seen. As the moon's gravity pulls harder, the air itself would become unstable, whipping up fierce winds and triggering massive storms that could rage non-stop. These wouldn't be ordinary storms. Think of hurricanes on steroids swirling across continents with relentless power. The interaction between charged particles from both Earth and the moon could even spark intense electrical storms, lighting up the sky with bolts far stronger than any lightning we know. This atmospheric turmoil would disrupt global weather patterns, making it nearly impossible to predict what comes next. Crops would fail, ecosystems would be thrown off balance, and the very air we breathe could become hazardous. The moon's approach would turn our skies into a battleground of natural forces, leaving no corner of the planet untouched. It's a stark reminder that the moon isn't just a silent companion lighting up our nights, it's a powerful force shaping life on Earth in ways we often overlook. As the chaos builds, survival would become a daily challenge, and humanity would have to adapt quickly or face the consequences of a planet thrown out of balance. Atmospheric and environmental chaos. The moment the moon crashes into Earth, the sheer force unleashed would be beyond anything humanity has ever witnessed. This isn't just a big explosion, it's a cataclysmic event releasing energy equivalent to billions of nuclear bombs detonating at once. The impact would instantly vaporize everything near the collision site, turning solid ground into molten rock and sending shockwaves racing around the globe. Debris from the collision would be hurled into the atmosphere and beyond, creating a fiery rain of molten fragments that would ignite wildfires worldwide. The sky would fill with thick clouds of dust and ash, blocking out sunlight and plunging the planet into darkness. This sudden blackout, known as an impact winter, could last for months or even years, causing temperatures to drop drastically and disrupting the delicate balance of life. Plants would struggle to survive without sunlight, and the collapse of ecosystems would ripple through the food chain, threatening countless species with extinction. The moon's collision wouldn't just reshape the surface of Earth, it would rewrite the story of life itself, forcing every living thing to face an uncertain and hostile world. This event would mark one of the most dramatic turning points in Earth's history, a reminder of how fragile our planet's stability truly is. Collision impact energy. So what would actually happen after the moon's catastrophic impact with Earth? Well, the immediate aftermath would be a global firestorm of unimaginable scale. The tremendous energy from the collision would superheat the atmosphere, igniting every combustible surface across continents. Forests, cities, everything would be engulfed in an inferno. As these firestorms raged, they'd pump colossal amounts of soot, ash, and greenhouse gases into the atmosphere, creating a thick, dark shroud that would completely block out the sun for months or maybe even years. This extended period of darkness, known as an impact winter, would cause global temperatures to plummet drastically. Photosynthesis, which is the fundamental process supporting most life on Earth, would just grind to a halt. The chilling temperatures, combined with the lack of sunlight, would decimate plant life, leading to a catastrophic collapse of food chains. The air itself would become unbreathable, filled with toxic gases and fine particles from the fires and pulverized debris. Surviving any initial impact would only be the beginning of a desperate struggle against a dying world, one that's been transformed into a barren, frozen landscape where the conditions for life as we know it would basically cease to exist. Global firestorms and darkness. When the moon collides with Earth, it won't just shake the planet, it'll fundamentally alter how our world spins. The impact's immense force would change Earth's rotation speed, possibly making days longer or shorter in ways we just can't predict. Imagine waking up to a day that lasts 30 hours or maybe just a few minutes shorter than usual. Our entire sense of time would be thrown off. The collision could even tilt Earth's axis, which is what gives us our seasons. Even a slight change in this tilt could lead to extreme climate shifts, with some regions facing brutal, never-ending winters, while others deal with scorching, relentless summers. This disruption to Earth's natural rhythms would affect everything: weather patterns, animal migration, and plant growth cycles. Over time, these changes could make huge parts of the planet hostile to life as we know it. The delicate balance that's allowed civilizations to thrive for thousands of years would be shattered, forcing humanity to adapt to a drastically different environment. It's a stark reminder that the moon isn't just a pretty object in the night sky. It actually plays a vital role in keeping our planet stable and life-supporting. Without it, Earth's future would be uncertain and filled with challenges we can barely imagine. Changes to Earth's rotation and orbit. The aftermath of a Moon-Earth collision wouldn't just leave a scar on the surface. It would create a massive cloud of debris orbiting our planet. This debris, made up of pulverized rock and dust, could actually form a spectacular ring around Earth, kind of like Saturn's iconic bands. Over time, some of this material might clump together, gradually forming a new moon. But this new satellite wouldn't be the gentle, familiar moon we know. It could be irregularly shaped, unstable, and constantly shifting. This debris ring or new moon would dramatically affect Earth's tides, possibly causing unpredictable flooding and altering marine ecosystems. Nights could become brighter or darker, depending on the density of the debris, disrupting animal behaviors and human activities alike. The constant presence of this debris would also pose a hazard to satellites and spacecraft, making it a lot more complicated to explore space or use the satellite technology we rely on for communication and navigation. This cosmic aftermath would remind us that even after a catastrophic event, the universe keeps moving, reshaping itself in ways that are both beautiful and dangerous. Life on Earth would have to adapt, not just to the immediate destruction, but to a changed celestial environment that could influence our planet for thousands, if not millions of years. Formation of a new debris ring or moon. So, the collision between the moon and Earth would trigger an extinction-level event unlike anything in recorded history. The immediate shockwaves, massive fires, and impact winter would, devastate ecosystems, wiping out countless species in just a matter of weeks. But the ripple effects would extend far beyond the initial disaster. Food chains would collapse as plants die off from lack of sunlight, and animals would really struggle to find enough resources to survive. Human civilization, which is so dependent on stable climates and agriculture, would face unimaginable challenges. Societies might collapse under the strain of famine, disease, and social unrest. Yet, even in the face of such destruction, life has a remarkable ability to endure. Microbial life, hidden deep underground or in the oceans, could survive the harsh conditions and serve as the foundation for eventual recovery. Over thousands or even millions of years, new species might evolve to fill the ecological niches left vacant. This event would mark a brutal reset for life on Earth, but it wouldn't necessarily be the end. It's a powerful reminder of both the fragility and resilience of life, showing just how closely our fate is tied to the cosmic forces that shape our planet. Potential extinction-level event. The moon crashing into Earth would unleash geological chaos that reshapes the planet for millions of years. The impact's force would fracture the crust, triggering massive volcanic eruptions worldwide. These eruptions would spew ash and lava, further darkening the skies and poisoning the air. Mountains could rise or crumble, and new landforms would emerge as the Earth's surface is violently rearranged. This geological upheaval would not only change the landscape, but also disrupt the planet's internal heat flow, potentially altering tectonic activity for ages. Earthquakes would become more frequent and severe, making the ground unstable and dangerous. Over time, these changes would create a planet that looks and feels completely different from the one we know today. The scars of the collision would be etched into the very bedrock, a permanent reminder of the cosmic disaster. Yet this process of destruction and renewal is part of Earth's natural cycle, though on a scale far beyond anything experienced in human history. It's a powerful testament to the dynamic nature of our planet and how it responds to forces from beyond our world, forever changing the stage on which life plays out. Long-term geological changes. The aftermath of a Moon-Earth collision would raise a crucial question. Could life ever bounce back from such devastation? Despite the overwhelming destruction, Earth's resilience is remarkable. Deep beneath the surface, microbial life forms could survive the harsh conditions, tucked away from the worst of the fires, radiation, and freezing darkness. These tiny survivors would become the seeds of a new beginning, slowly repopulating the planet's ecosystems over millions of years. Evolution would take its course, with new species emerging to fill the void left by those wiped out. However, this recovery wouldn't be quick or easy. The planet's environment would be radically altered, with unstable climates and landscapes posing constant challenges. Human civilization, if it survived, would have to adapt to a world unrecognizable from the one we know today. This long road to recovery highlights the incredible tenacity of life and the delicate balance that sustains it. While the moon's collision would mark an end to an era, it wouldn't necessarily spell the end of life itself. Instead, it would reset the clock, offering a harsh but fascinating glimpse into nature's ability to endure and evolve, even after the most catastrophic events. Could life ever recover? The moon's collision with Earth would be a cosmic catastrophe, but it also reveals something profound: the fragile yet extraordinary balance that sustains life on our planet. This event would shatter the harmony that has allowed ecosystems to flourish and civilizations to rise. Yet it's a powerful reminder that Earth exists within a vast and dynamic universe, where celestial bodies constantly influence one another in ways both subtle and dramatic. The moon's presence stabilizes Earth's tilt, moderates tides, and even affects the length of our days. Without it, or after such a catastrophic collision, the world would be unrecognizable, chaotic, unstable, and harsh. But this scenario also highlights humanity's place in the cosmos. Small, vulnerable, yet capable of incredible resilience and adaptation. While the moon crashing into Earth is an almost impossible event, thinking about it helps us appreciate the delicate cosmic dance that makes life possible. It encourages us to protect our planet and understand our universe better, knowing that even the most familiar celestial neighbor plays a vital role in the story of life. So, next time you look up at the moon, remember, it's not just a glowing rock in the sky, but a guardian of Earth's balance and a key player in the ongoing saga of our planet. Thanks for joining us on Space Facts today. If you enjoyed exploring what would happen if the moon collided with Earth, make sure to hit that bell icon so you never miss out on our cosmic discoveries. Don't forget to subscribe for more mind-blowing space content delivered straight to your feed. We'd love to hear your thoughts. Drop a comment below and tell us which space fact amazed you the most, or what topic you want us to cover next. Stay curious, and keep looking up. Neptune is spinning through space right now at speeds that would, honestly, obliterate Earth in seconds, hiding secrets so deadly that just knowing them might make you appreciate our fragile blue planet in ways you never imagined. This ice giant doesn't just kill, it transforms matter itself, creating diamond rain while unleashing the fastest winds in our solar system at over 2,100 kilometers per hour. But here's what will blow your mind. If you fell into Neptune, you'd experience the universe's most elaborate death sentence. Do you know what would happen to your body in those final 30 seconds? The freezing journey begins. You're about to experience the most terrifying 30 seconds of your life, and there's absolutely nothing you can do to stop it. The moment you cross into Neptune's atmosphere, your body becomes a science experiment gone horribly wrong. At negative 218 degrees Celsius, the cold doesn't just bite, it instantly crystallizes the moisture in your eyes, turning your tears into tiny ice shards that scratch your corneas. But here's the twisted part. You're still conscious for those first few seconds, feeling every single cell in your body begin to freeze from the outside in. Your skin hardens like plastic wrap left in a freezer, cracking with each desperate breath you try to take. The hydrogen and helium mixture surrounding you offers zero oxygen, so your lungs are already screaming for air that will never come. Your blood starts thickening like syrup, making your heart work overtime just to pump it through your rapidly constricting veins. The atmospheric pressure builds so quickly that your eardrums don't just pop, they implode, sending waves of excruciating pain through your skull. Within 15 seconds, your body temperature has dropped so dramatically that your nervous system begins shutting down, starting with your extremities. Your fingers and toes go completely numb, then your arms and legs follow suit. The last thing you'd feel before losing consciousness completely is the bizarre sensation of your own breath condensing and freezing inside your throat, creating ice crystals that block your airway entirely. Crushing atmospheric pressure. You think Earth's worst hurricanes are terrifying? Neptune laughs at your Category 5 storms while unleashing winds that move at 2,100 kilometers per hour. That's actually faster than the speed of sound itself. These aren't just strong breezes that knock over trees, these are supersonic death machines that would literally rip your body apart at the molecular level. The moment these winds catch you, your skin doesn't just tear, it gets shredded like paper in a blender, peeling away in microscopic strips that get carried away faster than your brain can register the pain. Your clothes disintegrate instantly, followed by layers of muscle and tissue being stripped from your bones in a grotesque spiral pattern. But here's what makes it even more horrifying. These winds are so powerful they create pressure waves that compress and decompress your internal organs repeatedly, like someone squeezing and releasing a stress ball made of your liver and kidneys. Your ribcage flexes beyond its breaking point, snapping ribs like twigs while your lungs collapse and reinflate violently. The wind doesn't just move you, it turns you into a human projectile, slamming you through layers of increasingly dense atmosphere at speeds that would make a bullet jealous. Your bones shatter from the impact forces, creating a cloud of bone fragments that get swept up in the same winds that destroyed you. Within seconds, what was once a human being becomes nothing more than a scattered collection of organic particles, dancing in Neptune's eternal atmospheric fury, forever part of the most violent weather system in our solar system. The methane and hydrogen hell. What if I told you that Neptune literally rains diamonds, and you're about to become part of the most expensive shower in the universe. As you plummet deeper into this ice giant's atmosphere, the extreme pressure and temperature create something that sounds like a fairy tale but is actually your worst nightmare. The methane in Neptune's atmosphere gets compressed so intensely that carbon atoms rearrange themselves into pure diamond crystals, and these aren't tiny specks of glitter. We're talking about diamond chunks the size of hailstones pelting your body at terminal velocity. Each crystal hits you like a bullet made of the hardest substance on Earth, puncturing through whatever frozen remains of your skin still cling to your bones. But here's the truly insane part. These diamonds are forming inside your body too. The methane you've been forced to inhale is crystallizing in your lungs, throat, and stomach, creating razor-sharp diamond fragments that slice through your internal organs from the inside out. Your bloodstream becomes a river of liquid carrying microscopic diamond dust, turning your circulatory system into sandpaper that grinds against your blood vessel walls. The pressure is so immense that any carbon-based molecules in your body, which is basically everything that makes you human, start transforming into diamond structures. Your bones, your muscles, even your DNA begins crystallizing into the most beautiful and deadly gemstones in the solar system. You're not just dying in a diamond rain, you're becoming part of it, transformed into precious stones that will fall through Neptune's atmosphere for eternity. Diamond rain phenomenon. You're about to discover why Neptune's core is the most contradictory place in our solar system. A hellish furnace buried inside a frozen wasteland. After surviving the diamond rain and supersonic winds, you're now descending toward a core that's actually hotter than the surface of the sun itself, reaching temperatures of 5,000 degrees Celsius. This isn't just hot enough to melt steel, it's hot enough to vaporize diamonds instantly, turning those beautiful crystals that were shredding your body into superheated gas. But here's where physics gets absolutely mind-bending. You're simultaneously being crushed by pressure that's millions of times stronger than Earth's atmosphere while being cooked alive by temperatures that could power a small star. Your body, if any recognizable pieces still exist, would undergo a complete phase transition, not just melting, but turning directly from solid to plasma, skipping the liquid state entirely. The core itself is a bizarre mixture of rock, ice, and metallic compounds compressed into a state of matter that doesn't exist anywhere on Earth. The pressure is so intense that water ice becomes as hard as steel, while metals flow like liquids despite the scorching heat. Your atoms don't just separate, they get crushed together so tightly that electrons start behaving in ways that just totally defy normal chemistry. The gravitational forces are pulling you inward with such violence that your molecular structure stretches like taffy before snapping apart completely. You're not just dying, you're being transformed into exotic matter that exists nowhere else in the universe, becoming part of Neptune's mysterious core where honestly the laws of physics bend to their absolute breaking point. Wind speeds beyond imagination. Neptune's magnetic field isn't just tilted, it's completely insane. Positioned 47 degrees off-center and spinning like a cosmic washing machine that's lost its balance. This isn't your typical planetary magnetosphere that protects life. This is a radiation death trap that's actively trying to cook you from the inside out. As you fall deeper, charged particles start bombarding your body with the intensity of 1,000 X-ray machines firing simultaneously. Your DNA doesn't just get damaged, it gets completely scrambled, with radiation tearing through your cells and rewriting your genetic code in real time like a cosmic computer virus. The magnetic field lines twist and spiral in ways that create pockets of concentrated radiation so intense they would make Chernobyl look like a gentle sunbath. These invisible energy streams slice through whatever remains of your body, ionizing your atoms and turning your blood into a radioactive soup. But here's the truly terrifying part. The magnetic field is constantly shifting and flipping, creating electromagnetic storms that generate electrical currents directly through your nervous system. Your brain gets fried by electrical surges that are millions of times stronger than a lightning bolt, while your heart tries desperately to beat against electromagnetic interference that's scrambling every electrical signal in your body. The radiation exposure is so severe that your cellular structure begins breaking down at the quantum level, with individual atoms losing electrons and becoming unstable isotopes. You're not just being killed by radiation, you're being transformed into a walking nuclear reaction, with your own body becoming radioactive enough to power a small city. The mysterious core approach. Time itself becomes your enemy, as Neptune's gravity warps reality around you in ways that would make Einstein weep. One day on Neptune lasts 16 Earth hours, but here's the mind-bending part. As you fall deeper into this gravitational monster, time starts moving differently for you compared to anyone watching from Earth. The massive gravitational field creates what scientists call time dilation, meaning every second you experience feels normal to you, but to observers on Earth, you're moving through time like molasses. Your final moments of agony get stretched out across what feels like an eternity to the outside universe. But from your perspective, something even more disturbing happens. Your biological clock starts going haywire as your brain tries to process the changing gravitational forces. The part of your brain that regulates circadian rhythms gets completely scrambled by the intense gravity, making you feel like you're experiencing days and nights that just don't exist. Your body's natural 24-hour cycle becomes meaningless, as Neptune's rapid rotation creates a disorienting strobe effect of light and darkness that happens faster than your brain can adapt to. The gravitational time dilation also means that different parts of your body are literally aging at different rates. Your feet, being closer to Neptune's center, experience time slightly slower than your head. This creates a horrifying biological paradox where your body starts aging unevenly, with cellular processes happening at different speeds throughout your organs. You're not just dying in space and time, you're being torn apart by time itself, experiencing your final moments in a temporal nightmare that defies human comprehension. Magnetic field chaos. You've just crossed the event horizon of your own destruction, the point where Neptune's gravity becomes so overwhelming that even if you had a rocket ship, you couldn't escape. This isn't like jumping off a cliff where you might survive with the right equipment. This is physics saying absolutely not to any hope of rescue. Neptune's escape velocity is 23.5 kilometers per second. That's over 84,000 kilometers per hour. And you're already past the point where that speed is achievable. Your body is now property of this ice giant, claimed by gravitational forces that are 11 times stronger than Earth's. But here's what makes this moment truly terrifying. You can feel your body stretching like a rubber band as the gravity at your feet becomes significantly stronger than the gravity at your head. This process, called spaghettification, doesn't happen gently. It's like being on a medieval torture rack that's operated by the laws of physics themselves. Your spine elongates vertebra by vertebra, creating gaps between your bones that fill with fluid before your nervous system finally gives up trying to send signals through the increasing distance. Your arms and legs stretch until your joints dislocate with audible pops that echo through the thin atmosphere. The gravitational gradient is so steep that your blood starts pooling in your lower extremities, creating a horrifying biological traffic jam as your heart struggles to pump against forces it was never designed to handle. Your internal organs begin shifting position inside your body cavity, sliding toward your feet like contents of a bag being held upside down. There's no coming back from this point. You're committed to becoming part of Neptune's mass, adding your atoms to this cosmic giant forever. Time dilation effects. This is where your existence as a human being officially ends and you become something else entirely. A cloud of subatomic particles scattered through Neptune's atmosphere like cosmic dust. The combination of crushing pressure, extreme temperature, radiation bombardment, and gravitational forces has pushed your molecular structure beyond its absolute breaking point. Your atoms, which have been held together by electromagnetic forces for your entire life, finally surrendered to the overwhelming physics of this alien world. The chemical bonds that make up your DNA, your proteins, your very essence as a living organism, snap apart like overstretched rubber bands. But you know, this isn't a gentle dissolution. It's a violent molecular explosion where every atom in your body gets ripped away from its neighbors and sent flying in different directions at incredible speeds. Your carbon atoms join the methane in Neptune's atmosphere, your oxygen becomes part of the water ice crystals, and your hydrogen merges with the planet's primary atmospheric component. The calcium from your bones gets crushed into exotic crystalline structures that exist nowhere else in the universe, while the iron in your blood becomes part of Neptune's metallic core. What's truly mind-boggling is that your atoms don't just disappear, they become permanent residents of this ice giant, cycling through its atmospheric layers for billions of years. The nitrogen that once carried thoughts through your brain will spend eternity swirling in Neptune's storms, while the phosphorus from your cellular energy systems joins the planet's mysterious chemical processes. You haven't just died, you've been completely integrated into an alien world, your very atoms becoming part of the most distant planet in our solar system. The point of no return. You're experiencing something that no human has ever survived. The complete transformation from a living, breathing person into scattered cosmic particles floating through the most hostile environment in our solar system. Your journey through Neptune's layers has been a masterclass in how the universe can dismantle a human being in the most spectacular and terrifying ways possible. Every single atom that once made up your thoughts, your memories, your dreams, and your fears is now permanently woven into the fabric of this ice giant's atmosphere. The hydrogen that carried oxygen through your bloodstream is now part of Neptune's endless storms, while the carbon that formed your muscles and organs has joined the planet's methane clouds. Your consciousness, that mysterious spark that made you uniquely human, has been extinguished and replaced by pure physics, your atoms following the laws of thermodynamics and quantum mechanics instead of biology and emotion. But here's the strangest part of this cosmic horror story. In a way, you've achieved a form of immortality that no human has ever experienced. Your atoms will circle Neptune for billions of years, participating in diamond rain, supersonic winds, and magnetic field fluctuations, long after Earth itself has been consumed by our dying sun. You've become part of something far larger and more ancient than human civilization, a planetary system that has existed for over 4 billion years and will continue spinning through space long after our species is forgotten. Your death wasn't just an ending, it was a transformation into something eternal, scattered across an alien world at the edge of our solar system. Final molecular disintegration. So there you have it. Falling into Neptune isn't just death, it's the most elaborate and scientifically brutal way the universe could possibly end your existence. From the moment you hit that frozen atmosphere to your final molecular breakdown, you'd experience every conceivable form of cosmic torture that physics has to offer. The freezing temperatures, bone-crushing pressure, diamond rain, supersonic winds, radiation bombardment, gravitational stretching, and complete atomic disintegration would turn your 30-second fall into the most intense and terrifying experience imaginable. But here's what really gets me. Your atoms don't just disappear into nothingness. They become part of Neptune forever, cycling through its storms and participating in phenomena that we're still trying to understand. In a twisted way, falling into Neptune would make you more connected to the cosmos than any human has ever been. You'd literally become part of an alien world, your very essence scattered across a planet that's been spinning at the edge of our solar system since before life existed on Earth. What do you think is the most terrifying part of this journey? The instant freezing, the diamond rain, or the fact that your atoms would be trapped on Neptune for billions of years? Drop your thoughts in the comments below. And if this made you appreciate Earth's atmosphere a little more, hit that like button. Trust me, after learning about Neptune's deadly embrace, you'll never complain about Earth's weather again. And hey, if you want to explore more cosmic nightmares, subscribe because we're just getting started with the universe's most creative ways to end human existence. That's the terrifying reality of Neptune, a cosmic death machine disguised as a beautiful blue planet. Your 30-second journey would rewrite the laws of human survival in the most spectacular way possible. If this cosmic nightmare made you grateful for Earth's gentle atmosphere, smash that like button and let me know in the comments which part shocked you the most. Don't forget to hit the bell icon so you never miss our latest space revelations, and subscribe to Space Facts for more mind-blowing cosmic content that'll change how you see our universe. Until next time, keep looking up. Every atom in your body was once part of a star that lived and died long ago. That's not poetry, it's science. The stars above aren't just beautiful, they're the reason we exist. We are literally made of star stuff. Ancient civilizations worship them. Today, we know stars are born, they burn, and they die in explosions so powerful they reshape galaxies. So when you look up tonight, ask yourself, what are you really seeing? A light show, or the history of everything? Let's uncover the life and death of the stars and why their story is also ours. The birth of a star. Stars are born in the cold, dark expanses of space within massive clouds of gas and dust known as nebulae. Imagine these nebulae as vast cosmic nurseries where the ingredients for new stars are scattered across the universe. These clouds contain the raw materials, hydrogen, helium, and dust particles, that, when compressed under the immense force of gravity, can give birth to something incredible. Gravity is the star's first catalyst. It slowly pulls the gas and dust together, causing the particles to collide and condense, making the cloud denser and hotter. This process takes thousands to millions of years, depending on the size of the nebula. As the gas and dust compress, a new hot and dense core forms at the center called a protostar, but it's not quite a star yet. The protostar is still in the process of gathering mass and energy. The temperature and pressure inside this core continue to rise, and once they hit around 15 million degrees Celsius, something incredible happens. Nuclear fusion ignites. This is the moment when a star is truly born. Hydrogen atoms in the protostar's core start to fuse into helium, releasing vast amounts of energy. This fusion creates light and heat, causing the star to shine brightly. And just like that, a new star is lighting up the cosmos. The process continues, and as the star stabilizes, it enters the main sequence phase, which can last for billions of years. Stars may begin from the most ordinary of elements, but through the forces of gravity, pressure, and time, they evolve into shining beacons in the night sky, marking the birth of something far greater than just light. It's the beginning of a stellar life cycle that will span millions, sometimes billions of years. Main sequence. After a star is born and nuclear fusion takes hold, it enters what we call the main sequence phase. This is the star's stable period, where it spends the majority of its life. Think of it as the star's middle-aged phase, where everything is calm, stable, and most importantly, shining. The star is constantly fusing hydrogen atoms into helium in its core, a process that releases an incredible amount of energy. This energy is what powers the star and gives it its brilliant light. For a star like our Sun, the main sequence lasts for about 10 billion years. That's right, a star is in this phase for a very long time. During this phase, the star has reached a perfect balance. On one side, the energy produced by nuclear fusion creates outward pressure, which tries to expand the star. On the other hand, gravity pulls inward, trying to collapse the star. These two forces, gravity and fusion, counterbalance each other perfectly, keeping the star stable and glowing. For most stars, this is the longest period of their lives. They shine steadily, providing light and heat to their surrounding planets, and if they're lucky enough, they might even give rise to planets with life, like Earth. The main sequence is an incredibly important phase in the life of a star. It's during this time that stars reach their full luminosity, and for us on Earth, it's what allows the stars in the night sky to shine brightly. But just like every good thing, the main sequence phase must eventually end. But before we dive into what happens when the star runs out of fuel, let's just take a moment to appreciate this balance that makes stars like our Sun such essential players in the cosmic drama. This phase represents the peak of a star's vitality, and without it, the rest of the stellar journey wouldn't even be possible. Red giant phase. As a star like our Sun enters the later stages of its life, its hydrogen fuel in the core begins to run low. But don't think that means the end is near. This is just the beginning of one of the most dramatic changes a star will undergo. When the hydrogen runs out, the core starts to contract under gravity's pressure, and in response, the outer layers of the star begin to expand, cool, and take on a reddish hue. Welcome to the red giant phase, where the star grows into a colossal, glowing sphere. At this point, the star's core is much hotter than before, which allows the fusion of heavier elements like helium. As helium atoms fuse together, they form carbon and oxygen, and the fusion process generates even more energy. This energy causes the outer layers of the star to expand massively. In fact, a red giant can grow to be hundreds of times the size it was during its main sequence phase. If our Sun were to go through this stage, it would expand so much that it could engulf Mercury, Venus, and even Earth. Imagine our planet, once teeming with life, now being swallowed by a massive red-hot ball of gas. But even as the star swells in size, things are beginning to change beneath the surface. The increased temperature causes the outer layers to become unstable, leading to massive stellar winds that blow away the star's outer material. In some cases, these winds can carry away up to a third of the star's mass. As the star grows, it starts to shed its outer envelope, leaving behind a dense core. This core will eventually become what's known as a white dwarf, the next phase in the star's journey. While this red giant phase might seem chaotic, it's actually one of the most fascinating stages in a star's life. The transformation from a stable, burning furnace into a massive, unstable behemoth is an awe-inspiring sight, and it's during this time that some stars make their most significant contributions to the universe, creating the heavier elements needed for future star systems and planets. Supernova explosion. For stars that are much more massive than our Sun, the red giant phase is just the beginning of a fiery and explosive end. These stars, once they have exhausted their core hydrogen, undergo a more dramatic and intense series of events that lead to the birth of one of the most magnificent phenomena in the universe, the supernova. But how does this happen? It all starts when the core of a massive star starts fusing heavier elements like carbon, neon and oxygen into even heavier elements like iron. However, when the core finally forms iron, something changes. Unlike lighter elements, iron cannot undergo fusion to release energy. This creates a major problem for the star. Without the energy from fusion to counteract gravity, the core begins to collapse. The pressure from this collapse causes the outer layers of the star to implode inward at incredible speeds. As the outer layers crash into the dense core, they are thrown outward in a cataclysmic explosion. This is a supernova, a violent, explosive event that releases more energy in a single burst than our sun will release throughout its entire lifetime. The explosion is so powerful that it can briefly outshine an entire galaxy. During this brief period, the supernova becomes the brightest object in the sky, visible across vast distances. These explosions scatter the star's outer layers into space, enriching the interstellar medium with heavy elements like gold, uranium, and iron. Elements that are crucial for the formation of planets, life, and everything we see around us. Supernovae are essentially the universe's recycling process, creating new building blocks for future stars and planetary systems. But not every star dies the same way. While smaller stars will collapse into white dwarfs, the most massive ones undergo an even more fascinating fate: a neutron star, or, if the mass is great enough, a black hole. But before we delve into these stellar remnants, let's pause and appreciate the sheer cosmic power of a supernova. It's a spectacular end to a star's life and a beautiful beginning for the next generation of stars and galaxies. Stellar remnants. When a massive star explodes in a supernova, it doesn't just disappear into nothingness. What's left behind is a dense, compact remnant that is often more fascinating than the explosion itself. The fate of this remnant depends entirely on the mass of the star's core. There are two possible outcomes for the surviving core: a neutron star, or, if the core is heavy enough, a black hole. Neutron star. For stars with a core mass between roughly 1.4 and 3 times that of the Sun, the core doesn't collapse into a black hole. Instead, it becomes a neutron star, a celestial body so dense that its atoms essentially collapse into neutrons. A neutron star is incredibly small, with a radius of only about 10 kilometers, yet it packs more mass than our Sun. This density means that the star's gravitational field is extreme, and neutron stars are known to emit intense magnetic fields and fast-spinning beams of radiation, which we detect as pulsars. These pulsars can spin up to several hundred times per second, creating a cosmic lighthouse effect. Imagine the power of a star compressed into such a tiny, dense object. For stars with a core mass greater than about 3 solar masses, no amount of pressure can prevent the collapse. The core continues to shrink, becoming so compact that it forms a singularity, an infinitely small point with immense density. This process creates a black hole, a region of space where gravity is so strong that not even light can escape. A black hole doesn't suck everything around it like in the movies, but its gravitational pull is so strong that anything that ventures too close gets pulled in, never to escape. Black holes are mysterious and elusive, but they play a crucial role in shaping galaxies, as most large galaxies have a supermassive black hole at their center. These objects are both fascinating and terrifying, and we can only begin to imagine the mysteries they hold in the depths of their gravity wells. White dwarfs. While the fate of massive stars is marked by dramatic explosions and mysterious remnants, the path of smaller stars, those with less than 8 times the mass of our Sun, is equally fascinating but less violent. Instead of blowing up in a supernova, these stars end their lives as white dwarfs. For stars like our Sun, the transformation into a white dwarf is a quieter, more gradual process, but no less important in the cosmic cycle. When a star like our Sun runs out of hydrogen fuel in its core, it begins to shed its outer layers, releasing a glowing shell of gas and dust known as a planetary nebula. What's left behind is the core of the star, which becomes the white dwarf. A white dwarf is a small, dense object about the size of Earth, but with a mass comparable to that of the Sun. This incredibly dense remnant is made primarily of carbon and oxygen, supported against further collapse by electron degeneracy pressure, a quantum mechanical force that arises from the Pauli exclusion principle. In simple terms, this pressure prevents the electrons in the white dwarf from being squished together. Over time, white dwarfs slowly cool and fade, becoming dimmer and dimmer over billions of years. Eventually, they will no longer emit any light or heat, leaving behind a cold, dark relic of the once glowing star. These white dwarfs are not completely lifeless, though. In fact, the elements they contain are some of the building blocks for new stars, planets, and even life. The cosmic recycling process continues as the white dwarf's remnants, its carbon and oxygen, might eventually become part of a future generation of stars or planets. Even in death, the star has a profound impact on the universe, passing on the elements needed for new life to take shape. Stars with lower mass end their lives not with a bang, but with a whisper, a slow, silent fade into the cosmic background. But even in their quieter demise, they play a vital role in the ongoing creation of the universe. The cosmic recycling. The death of a star, whether through a supernova explosion, the slow fading of a white dwarf, or the quiet collapse of a neutron star, is not the end of the story. In fact, it's only the beginning of a new chapter in the universe's vast and ongoing cycle of creation and destruction. The elements that were once forged in the heart of a star, hydrogen, helium, carbon, oxygen, iron, and more, are scattered throughout space, enriching the interstellar medium and becoming the building blocks for the next generation of stars, planets, and even life. When a massive star dies in a supernova, the explosion blasts these elements into space at incredibly high speeds, often faster than the speed of light. This cosmic spray of material can travel across vast distances, carrying with it the very elements that are essential for the formation of new stars and planets. For example, our own solar system was likely formed from the remnants of earlier supernovae. The heavy elements that make up the Earth, including the iron in our cores and the oxygen in our atmosphere, were born from the death of ancient stars. Without these stellar deaths, life as we know it would not exist. But it's not just supernovae that contribute to this cosmic recycling process. White dwarfs, the remnants of medium-sized stars, also play a role in this cosmic game of life and death. Over time, as white dwarfs slowly cool and fade, they might still release their residual elements into the surrounding space. These elements could be incorporated into new star-forming nebulae, further fueling the creation of new stars and planets. Moreover, neutron stars and black holes, while seemingly the ultimate end for a star, are not entirely disconnected from the cycle of stellar creation. For example, neutron stars can emit strong bursts of radiation known as gamma-ray bursts, one of the most powerful phenomena in the universe. These bursts of energy can trigger the formation of new stars in distant regions, essentially reigniting parts of the galaxy into new life. Even black holes, with their immense gravitational pull, can influence the formation of new stars by pulling in nearby gas and dust, providing the necessary material for star formation in a process known as accretion. Thus, the death of a star is not a solitary event, it is an essential part of a greater cosmic cycle. Each time a star dies, it releases the ingredients for new beginnings, new stars, new planets, and potentially even new life. The universe, it seems, is forever recycling itself, and each stellar death is a crucial step in this ongoing process of creation. The birth and death of stars are, in a sense, two sides of the same coin, forever linked in the vast, ever-changing tapestry of the cosmos. Thanks for joining me on this incredible journey through the life cycle of stars. From their dramatic births in swirling clouds of gas to their spectacular deaths that seed the universe with new elements, stars truly shape everything around us. The next time you look up at the night sky, you'll see more than just points of light. You'll see stories of creation, destruction, and cosmic rebirth. Stay curious, keep looking up, and keep wondering about the vast universe we call home. And if you love discovering the secret of the universe, don't forget to like, subscribe, and hit the bell icon for more adventures.